We used to work together, but we don't anymore, but we still run the Seattle AWS Architects and Engineers Meetup. We have about 2,500 members in this meetup, and we're celebrating our 5th year anniversary in January, so if you happen to be in Seattle in January, come hang out with us and help us celebrate that. So we come to you today with diverse experience. I have about 25 years of software development, architecture, and engineering experience, as well as security experience. And I've done a number of different things in the realm of software architecture, including financial systems for Capital One, back office systems for Nordstrom, architected a SaaS IoT solution. Those are just some examples of some software development experience I have. I also have a number of security certifications. If any of you are familiar with the SANS GXPN, it's an advanced pen testing certification. I actually just got this last week. It's very challenging. But I don't just have certifications, I have real-world experience in security. And it started when I ran my own company prior to the one I run now, was a software consulting business. And I would have security breaches and incidents, and I didn't have anyone to help me. I had to just figure it out. I didn't know what to do sometimes. I had to figure out how the malware got on their systems and solve those problems. So now what I really like to do is help other people with their security. So the past few years I've been focusing primarily on cloud security. I really got into this because I looked at the cloud, and based on my experiences, I thought, well, some people could be more secure in the cloud potentially, but you have to configure things correctly. If you don't configure things correctly, you could have problems, and that's what we're going to talk to you about here today. So now I run my own software consulting business, cloud security consulting business called Second Sight Lab, and I help people with cloud security consulting, training, and pen testing. This past year I was teaching for SANS Institute, and I still have some good friends that teach there, some of them in the cloud. I taught the cloud security architecture and operations class, but next year I'm teaching my own classes, running my own classes that are going to be a little bit different, and they're really geared at helping developers and security people work together better like we're doing here on stage today.
So I'm Colby. So as Terry said, we've known each other for about 4 years, and we run the community group together and have worked together. I actually started life as a physical chemist, and so I started in chemistry. Got really tired of chemistry, and so liked the technology side of it and went into consulting. Started using AWS and got passionate about that, and I was able to move through a few different jobs. Currently, I work at ZipWhip, so we're a startup based out of Seattle. We provide landline and toll-free texting services for businesses to be able to communicate with their customers. And as Terry said, this talk is just kind of going to be about things that we've learned and done over the years with building stuff on Amazon.
Okay. So, as we said, we're going to talk to you about red team versus blue team on AWS. And if you're not familiar with those terms, the red team is a team that usually works inside of a company and simulates attacks on company systems and tries to find ways to break in and traverse the network and find security gaps and holes. And that team helps the blue team, who is the defensive team, the team that sets up the defenses, the security controls on the network and on the applications and tries to defend the environment. And there's a saying that offense informs defense. So the offensive team is going to attack the systems and be based on what they find. The blue team is going to make adjustments to secure the environment. You may have also heard the term pen testing, and just to get this out of the way, penetration testing or pen testing is usually done by an external company that comes in and tests the environment. Sometimes this is required for PCI compliance or otherwise. And some people debate what these terms mean. For our purposes today, we're kind of just talking about an attacker versus a defender. And so for today, I am going to be the stealthy ninja on the screen. I'm going to go into the account, and I'm going to try to attack it and see if I can get through and steal some of your data. And Colby's going to be Superman. He's going to come in and save the day. He's going to show you how to fix the problems that I find. So let's just get this out of the way. Whenever you're doing standard pen testing, one of the goals when the on-premises environment is to get domain admin. And what this means is the ultimate achievement of a pen tester is to get administrative credentials of the domain administrator. Because what does that mean? That means I can go in, I can create myself accounts, I can basically give myself permission to anything in your environment and do whatever I want. So in the cloud, we're calling this cloud admin. And if you get cloud administrator credentials, and if you've given your cloud administrator full credentials to everything in your account, I want to get those credentials because then I can do anything I want in your account. But if I was able to do that, this would be a really boring talk because it's pretty much game over, right? And there's actually a company that faced this problem you may have heard of called CodeSpaces. And I like to say it's the company that got deleted. Because what happened was an attacker got their credentials, demanded some money, said, give me some money or I'm going to do bad things in your account. And they said no. And so then the attacker proceeded to delete everything they had in their account. They hosted code and files for other companies, and all their customers' data was deleted, and they went out of business. So instead of talking about that, we want to do something a little more interesting. We're going to go on a treasure hunt. We're going to search for buried treasure. So your data is like your treasure. It's like your gold, right? It's the thing that you're trying to protect in your account. It's what's really valuable to you. Most of the time, this is the goal of attackers, to go in and get some data and steal it, as you've seen in many of the security breaches that have been in the news recently. And in order to attack your account and get at this data, I'm not going to use standard pen testing tools. You may have heard of Metasploit or PowerShell Empire. And there's actually, I have some friends that work for Rhino Security up in Seattle, and they created a cool tool called Pacu. And I like to say it's the Metasploit of AWS, right? It has functions you can use to try to get into the account. But we're going to use a different methodology. It's called living off the land. What this means is I'm not going to use any tools other than the ones that are already existing in your account. The things that your developers and your DevOps people are using, I'm going to use those tools and leverage them to traverse and get through your account and your network and figure out how I can get out at your data and steal it.
So before we dive in, we're going to kind of go over some background on how we set things up. So we treated this as if we had our manager ask us to go start deploying stuff on AWS. We spun up a brand new AWS account. We had a single user made, base VPC, and default. So we left it as vanilla as possible. We then realized, well, we want to deploy some type of web application, so we searched for some tutorials. We found an Elastic Beanstalk tutorial with WordPress. We followed that tutorial all the way through, so this is on Amazon's website. And then also, because serverless is fun and new, we decided to do something with serverless. And we have databases, so why not serverless and databases? So we looked up a tutorial on using Lambda with a relational database service, so RDS, and running that inside of your VPC. And so again, we just followed that tutorial exactly for how it was written and didn't do anything extra with the account.
Okay, so in this case, let's say that you were trying to be secure and you set up some users, but you did not give them full administrative access. You gave them read-only credentials. I want to get a hold of some of those credentials and see what I can do with them. And even though they're read-only, they may be able to help me out. So you may know this, but the credentials, when you use Amazon credentials, are stored in a file on a laptop, and they're in plain text. And so if I can get onto someone's laptop, I can grab those credentials and start using them. There's a number of different ways. Again, this is kind of outside the realm of what we're talking about here today, but standard pen testing techniques for getting in there and getting those credentials. I'll just give you a couple examples. I could send your developer a phishing email, say free ticket to reInvent or something, you know, and then I could go in there and I could try to get them to click on that email and grab those credentials by some sort of malware. I could also set up a drive-by download site. I could try to trick them into going to my site and getting some malware in their machine that way. Or I could just be really nice and try to use some social engineering and say, can I borrow your keys? There's a number of different ways that you can get at credentials on a machine. So let's say I got those credentials. What can I do with them? So the first thing I want to do is I want to know where your data is, and I want to know where your important data is. Now, I've worked for a lot of financial organizations, and I've worked with a lot of PII data, or protected data that you don't want someone to get at, and I know that a lot of times this type of data is stored in a database as transactional, or a relational database, and typically this is where I'm going to find data like that, so I'm going to start there. And using those credentials that are just read-only, I can run this query here, and I can say, show me all of the RDS databases in this account. And then I can look at the information about those databases, the metadata, and I can try to figure out which one I want to attack. In this case, Colby was really nice, and he named one of the databases the super secret DB. So let's see what's in that one. So what are the controls that I have to get through to get to this database? There's a few of them. There are some network controls. The first thing I have to get through is the network access control lists that are associated with subnets that this database is located in. So what I can do is I can query the subnets associated with this database, and I find two. And I can look at those, and I can use that subnet ID to go examine the network access control lists. The network access control lists are going to define the traffic that is allowed in or out of the subnet in which this database resides. So as you can see here, we have a series of rules, and in the case of a network access control list, the first rule that it matches will apply. We have some ingress rules, and we have some egress rules, meaning inbound and outbound. And in both cases, the first rule allows CIDR block 0.0.0.0/0, which means anywhere on the internet, on any protocol to get into the subnet. So this is a default that comes with subnets on AWS, and if you have a developer deploying their code and their resources, they may just go with the defaults. And so in this case, I know that from here on out, I don't have to worry about those subnets or those network access control lists because they're wide open. Anything in this subnet that is in the subnet can talk to this database. So the next thing I have to get through are the security groups, right? So now I have a database name, and it's associated with a particular security group ID, so I can go get that from the database, and I can plug it into this query right here, and I can say, show me the information about the security group as associated with this database. And what I find here is that this security group allows access inbound on port 3306, which tells me it's probably MySQL, right? And I can see that it is anything in the CIDR block 172.3100/16 is allowed to talk to my database. Okay, so I need to figure out what is in that particular CIDR block that can talk to this database. So how can I use this information? Well, I can look for VPCs and subnets, maybe that are assigned to this particular CIDR block to try to figure out, and lucky for me, I do query the VPCs, and I use the CIDR block, as you can see here, and I find out that the entire VPC is allowed to talk to my database on 3306. Anything in this database. Okay, so now what I want to do is I want to find out, okay, I know anything can talk to this database, but the thing that is talking to this database needs outbound access on port 3306. So let me see if I can figure out what is talking to this database that might help me. And I can look here and query on port 3306 outbound in this VPC, and I find another security group. So probably what's in this security group has permission to talk to this database. All right, so I know there's probably likely some compute resource, maybe Lambda or Fargate or maybe an EC2 instance, so I'm going to query those. And I'm going to see if any of them are using the security group, and of course I find one here. This is a Lambda function. It's named create table records and read, and it's based off of that tutorial that Colby showed you. And here's where it gets interesting. So when we were first playing around with this, trying to figure out what we were going to show you and what we were going to attack, I did a query of the Lambda function. You can use this function called get function, and it'll give you a whole bunch of information. And one of the values in there is called code.location. And this gives you back a URL. And what I noticed was when I went to this URL, I didn't have to have any credentials. I wasn't logged into my account, and I could get to it. I also sent it to Colby. I texted over to him to see if he could get to it, and he could. And so this is a time-based URL. You don't even need credentials in the account to see this. And this is by design. It's how it works. So if I can get access and read this information, then I can use this URL to go. And what does it show me? It shows me the code for the Lambda function. And how is this useful? Well, there's a lot of ways. If I can see your code, there's a lot of ways it's useful. I can look for vulnerabilities or configuration problems. I can look for programming errors. But in this case, I see a file here called rds_config. RDS. What could be in this file? Oh, it's database username and password. Don't do this. It's really bad. So you should never put your secrets in your code, right? Because if someone gets at your code, they can get your secrets. Now I can use these credentials, and I can log into this database. even though I only had read-only access. So how am I going to do that? Well, if I try to use this Lambda function, it's going to be a little tricky because these files, I don't really have access to them. I don't have write access to the account, so it's going to be a little challenging. So I'm going to think of another way to get in here. First of all, I need to get into an instance that has access to the internet. I need to find something I can attack and get in that way. So I can query your account to see all the EC2 instances that have a public IP or a public DNS name. And that might give me a clue as to what I can get into. And once I get in there, I can find some instances. Now I need to find out if these particular instances that I want to get into have access to our database. Now you may know this, but when you deploy a security group, if you don't specify any outbound rules by default, there will be a rule in that security group that says 0.0.0.0/0 on any port. That means that whatever resource you assign the security group to can talk outbound to anything else. So I'm going to hope that in this account you had some people that just use those default rules and set me up some security groups around some instance with some public internet access that I can use to get at this database. And sure enough, I found a whole list of security groups that have this default outbound rule. And one of them is associated with one of those instances. And when I go to that instance, I find out, hey, this is a WordPress website. Great. How does that help me? Well, now what I'm going to do is we're going back into kind of the land of standard pen testing. And what a pen tester or a red teamer will do is they will scan your externally exposed assets, for example, in this case, a WordPress website, looking for vulnerabilities, looking for CVEs, looking for problems in the code that they can exploit. And what I can do is once I find one of these vulnerabilities, only takes one, then I can get it onto that system. I can upload my code. I can use those database credentials that I stole earlier. I can grab the data from the database. I can just publish it to a public web page, and then I can scrape it and steal it, right? And so this is what I may try to do. And so there are a number of ways that you can attack these systems. I'll just give you an example. We did this talk at RSA, and I talked about how in a previous test I was able to get into a website that had a file upload field, and it was not properly sanitized, so I could upload any code I wanted, and then I could change the code. And so, lo and behold, after that talk, a new CVE came out in WordPress that is related that says, hey, if you don't properly, or you had a control that was not properly sanitized that allowed someone to get in there and upload a file and change something on that WordPress website. So all I need to do is find any published known vulnerabilities that you haven't patched appropriately or any sort of code flaw to get into that website. So in summary, what have I done? I stole some keys. I did some recon on your environment to find out what was in there, what I might attack, what kind of resources were there, what I might leverage. And then I found some database credentials. Cool, got those. I exploited a web server, and then that web server was allowed to, by poor network programming rules, I was able to get at the database, get the data out, and then exfiltrate it from the environment. And so we have a number of problems here. We have read-only permissions to the whole entire account. We have single-factor credentials, meaning no MFA, a wide-open network. We have secrets in code and more. And now, Colby's going to tell you how to fix it.
So, wow, I did a bad job. So let's go through and talk about all the different ways we can leverage AWS tools to make it better. So to begin with, everything I'm going to talk about is all built into AWS. I'm not going to use anything special. We're just going to go through and talk through some different tools. The first thing is protecting credentials, right? Terry was able to get a set of creds. So the biggest and easiest way to do this is user training. Protect your users, teach your users how to identify phishing campaigns, how to handle credentials. They shouldn't be sharing them. Even if it's a read-only credential, as we just showed, they're powerful, and so you shouldn't be sharing those. Password policies and rotation is important, right? So Terry was able to use those creds. I mean, we created those creds, and she used them over 3 months. I never rotated them once. And so during those 3 months, she could have kept going back in and continued exfilling data from our account. Require MFA, right? There was no MFA here. So once Terry had those credentials, she had all the auth pieces. There was no extra piece needed. Require frequent re-auth, especially to sensitive parts of your application or your infrastructure. so that those credentials are getting refreshed, and I'll go through some examples of this. And then as you saw, I put creds in code. I followed a tutorial that told me to do that. We need to protect against that. AWS has a tool that we can leverage in with Git called Git Secrets, which will go through and actually scan as a pre-commit hook for AWS credentials by default. And you can actually write your own regexes, because those are delightful to write, and integrate them yourself, right? So here's just an example, a Python script where we have the Boto 3 session coming online. We have a set of creds in there. I go try to check in the file. It doesn't let me. So you can roll this out to your developers just as that final sanity check to make sure credentials aren't being uploaded to Git, and you're protecting them there. So let's talk about IAM. So this is how she managed, did the main compromise. So how can we protect about this? So again, I'm not going to do an IAM top 10 talk. I'm just going to go over a few points that we've deemed important and methodologies that can help you do a bunch of things really easily that we've found useful. But there's a bunch of great IAM top 10 talks out there, and I recommend everybody to listen to them because they're all good. But the big thing that I'm going to focus on is going to be roles, least privilege, and segregation of duties. And I'm going to leverage roles to get me the last one for free. Okay? So I'm going to create a user, and this user is going to have the most minimum amount of permissions possible. Literally, they can manage themselves in IAM, and that is it. They can set an MFA token. They can't do anything else. And so we're going to go through and set these permissions up. And so I'm going to go through and show you this YAML to set this up. So we're going to give them some permissions. The first ones are just kind of some IAM console permissions. It's going to allow the user to view enough information so they can get into IAM and actually see themselves. We're going to let them get the password policy because we just said we're going to set a password policy. So we got to make sure they can get that and apply it. And then again, we'll let them list all the users. You probably could refine that, but this will let them find themselves in the list pretty easily. So this one's pretty generic. This is just to kind of get the console to work. From there, we're going to lock them down. So I'm going to give them only a very small set of privileges. And it's literally just privileges to change their IAM account permission, or not their permissions, but just change their IAM account. Important thing is I'm not going to let them change their permissions. Okay, so they can set their password, change their password, SSH keys to use some of the code star tools and different things like this. But we're going to use a special tag in IAM. So, this is a cool feature. I don't know if anybody's using this, but we're going to leverage this IAM tag that effectively, when you log in, it pulls in your user information. So our team that's managing IAM only has to create one set of templates to apply to all users. Because when you log in, it assumes your identity. And so that's that AWS :username. So we've limited who you can actually change. The next piece is we're going to do some MFA stuff, okay? We're going to let the user add MFA, and we're only going to let them add MFA, okay? We've decided, for us, we found that we don't want them to delete it. So the problem is if you let them delete MFA, if someone were to compromise a set of credentials, they could go in and remove the MFA, and now you don't have it anymore. This also lets you separate your IAM and your user control team from the team that's actually using AWS. They have to initiate, a ticket with your IT or something like that to have the MFA removed. You have two parties there, some type of ticketing or tracking system in place. So it gives you some good practices on how to handle that. Okay? So this user is going to have, like I said, very little to no permissions at all beyond setting passwords and enrolling themselves. Then we're going to add one final role or ability to the user, and that's the ability to assume set roles. Okay? And we're going to require some special things with this. So we're going to create a bunch of roles, and these roles are going to be very limited scope roles, right? Your network admin, your Kubernetes admin, whatever tool, and scope these down. We're going to require MFA to assume these roles, so they're going to have a two-factor auth into this. And then we're also going to put some time constraints around these roles. So these, more sensitive roles are going to have a lot less time that they're going to be able to be assumed than some of the other ones. And so your user now comes in, they have this default set of credentials, the ones that Terry compromised, but they can't do anything, besides change the user's password. They're going to require MFA to assume any privilege, and so we've protected the roles there. We're going to leverage the secure token system, so we're going to get back a temporary set of credentials that we can then use to do our action. But the important piece here is now is all those credentials are temporary. They all have some sort of expiration associated with that. So we can actually then define, your network admin has 15 minutes of access, and then they have to re-MFA in, and you're better protecting that network. And so you're able to require frequent re-auth a lot easier with this, leveraging the MFA or integrating with any type of auth source that you want. So what does this actually look like? So here's the same commands Terry ran against the account. So I have my default set of credentials as a user. All I can do is manage myself. And I try to describe the RDS instances, and I can't access it. I don't have the rights. I created a secure read-only role that does let me read the account for a set amount of time. I assume it. The important thing, though, is I required MFA to assume that role. So I assume into it. I have my second factor of auth and can get into it. I'll get back a set of temporary credentials. The key there is they are temporary. We get back an expiration time on when those credentials are no longer valid. We then leverage those credentials, run the command, I get the things back. These credentials are going to expire. They no longer will work after a set amount of time, and then we have to re-auth. And so they're not just sitting around for months on end, sitting there for someone to exploit. Once they're done, they're done. Okay? So that lets us go through and manage the credentials. We can also be proactive in monitoring these credentials. So I'm assuming everybody in the room who uses AWS uses CloudTrail. You should, because new accounts have it on by default now. So CloudTrail is going to monitor all of those API actions for us. And so we'll be able to see what all of our users are doing. Okay? And we can monitor them all. The nice thing is, like a lot of Amazon services, these go into some type of event stream. That event stream we can subscribe to and we can do stuff with it. And so we can create Lambda functions that watch for certain types of actions. And so we can actually respond back, whether that be paging some type of on-call team, sending a Slack message, or actually doing some auto-remediation against it to fix itself, so you're in real-time responding. You can also build profiles of your users. If you know that your team shouldn't be deploying servers outside of work hours, you can program this into a lot of your functionality and see what's happening and taking place. The attacker, is going to be doing stuff at different times, and you can slowly see what's going on there. This will also let you track users that have permissions to things they shouldn't have access to. It lets you track, did you remove that user's ability to do certain actions once they change teams? And so we have those there. But it's important that we can subscribe to this, and then we can get into that more real-time blue team type effect of responding to the events as they happen. Okay? So that's our IAM. The next is secrets. So I messed up really bad on secrets. She had them in plain text. So we're going to talk about secret management. Now, Amazon released AWS Secrets Manager. We're not going to talk about that. That tool is designed more for an RDS type application. It's a great tool. We're going to focus on EC2 parameter store for secrets. When using these, just look at which use case works better for you. In the example that we're using, this one works a little bit better for us. So EC2 parameter store is a secure location for us to store things, anything from key value stores to secrets. It's all controlled access-wise via IAM, so we can manage who can access it and who can't, and so we can set things up. The nice thing is it also integrates tightly with KMS, so we can encrypt the data that sits inside of it, which is perfect for secrets. So what we can do is we can actually then also take it one step further, since it's IAM, and do segregation of duties. We can build roles that let database administrators seed credentials into the store, lets them encrypt it, but doesn't let them pull data out. We then can roll out instances that have roles attached to them that has the ability to pull credentials out and also decrypt it. And so we're able to control that. And what's nice is we can control it 2 levels, at the parameter store level, and then also the ability to leverage the KMS keys for encryption and decryption. And so we can actually protect the credentials and know what's going on here. The other nice thing is because using IAM, all of the actions are tracked in CloudTrail, so we can watch what's happening. So if credentials are being seeded at weird times in the night when you know your DBAs aren't online or your IT team isn't online doing that, you can respond accordingly. You can also track what instances are getting secrets out. So you can track and say, okay, well, that instance no longer needs a secret. we need to adjust those IAM roles in order to make sure that instance really is acting under the most minimum amount of permissions possible for it to do its job. So again, just an example of what this looks like. So left side's the file Terry showed you, right? It's got the password in it. The right side is the new file, no password in it. And it's pretty minimal amount of work to get this set up. In Python, it's only 3 lines of code for us to set this up. So we just call into the parameter store. We can pull the data out, and you leverage it for our application and use it. And if we look at the AWS console, it's there, and based off your console access, you can either see or not see the credential. So what's also nice is for those people that are using IT teams to store secrets, they have a console that they can go in and do this in. Since the encryption is managed by KMS, we get all the nice KMS features of key rotation in the back end, that come for free with that we don't have to manage. So to do this is fairly minimal amount of work. It's not a lot of extra code. And we're able to make this quick change, and now she no longer has the database secrets. And especially with us discovering that Lambda link is public for a set amount of time, so people can't go and download that. So now let's discuss some more of the monitoring side of things. So those previous ones cover some of the proactive stuff we can do. Let's talk about more of the reactive stuff to do. So for monitoring, the big one that we can start leveraging is guard duty. So who in the room uses guard duty? Right? It's an awesome tool. It was released, I think, last year at reInvent. And so guard duty is going to analyze VPC flow logs, DNS logs, and your CloudTrail logs, and kind of build a profile on your account of actual usage, and then start alerting based off of anomalies outside of that regular usage. It also has a set of heuristics programmed into it that it'll watch for, like brute force attempts and things like that. It learns your account for the first 30 days, and then after there, it builds a profile. It's really interesting. So it learns your account for the first 30 days. So don't do what we did and set up an account and don't log into it for 30 days, because on 31 days, guard duty lets you know that something's going on that's not right. So you have that. Again, for monitoring with guard duty, it's like all the rest of the tools. There's an event stream that you can subscribe to, so you can watch the guard duty alerts come off and then do actions against those, whether that's just simple paging, posting to Slack, or actually building some type of remediation process in order to handle the exploit. Other monitoring, as we talked about, is look at CloudTrail. VPC flow logs are a good tool to make sure you know where all of your traffic's going. You should see profiles that look correct. AWS Config's an awesome tool to watch your account, watch and make sure no changes are taking place, and either roll back or alert you based off that. And then some non-AWS monitoring thing, make sure you ship your logs, you're watching your logs, securely backing those logs up. They're going to have information for you that you can work on. And then leverage any type of automated remediation as possible. So for those of you who haven't used guard duty, this is the guard duty console, just for everybody to see. So here's what's going on there. It builds these profiles, and it shows a lot of really cool information. By default, it's going to track like SSH brute force attacks, so you actually get to see how many people are trying to get into your stuff. Makes it a really good point for why you don't publicly expose SSH. It'll help find if there's crypto mining type actions taking place in your account, which is a fun exploit if anybody's had their account compromised for that one. They rack up bills real quick. And you can watch those things. Again, alert, black hole those instances for forensics later, or just delete them and get rid of them as needed. AWS does have some tools, too, to handle like CVE actions. So this is if you're not using immutable infrastructure. They have a system manager, which will go through and let you patch your systems through a very nice automated method. And so you can have it create profiles and documents that go through and patch the systems. Again, this works the same way that parameter store works, where IAM controls all of the access to this. So you can do two-party type creation of those documents, make sure you understand what's going into those. And then limiting which instances can talk to which things, storing secrets in the parameter store so that you can leverage those later. We can also leverage AWS Inspector to scan our account. And what's nice is, again, like I've said a few times now, is there's an event stream that we can subscribe to that we can trigger system manager calls out of. So we can actually use Inspector to trigger our auto updates to patch our system. If you're running immutable infrastructure, the system manager one's probably not as important to you. But inspector can trigger a roll of all your instances if you're running immutable and bring on new patched up-to-date instances so that you're protected there. And so again, these two tools are here and available for people to run and really protect their systems and be more proactive. So as Terry's scanning the environment, trying to find those CVEs and those exploits, we have something in the background running the whole time, scanning and protecting our own assets in order to make sure that Terry can't get the data off. The other problem we ran into is protecting external-facing resources, right? So Terry was able to exploit WordPress, which is a fun one to exploit. So there's a whole suite of tools and some cool things here that we can do that's actually very straightforward and very simple. So here we get CloudFront. This is kind of the core of what we have running here. And CloudFront is Amazon's CDN. And in front of CloudFront sits Shield, so we get some DDoS protection so that someone can't just DDoS the account, cause overflows or weird things to happen. But we can also tack on WAF, the Web Application Firewall. So we can protect against those SQL injections, cross-site scripting actions. We can auto-block any type of nefarious IP address that exists. These are auto-updating blacklists. We can create our own blacklists so that IPs that are hitting our system at rates that are not acceptable, they can get auto-blacklisted for permanent or set amount of time, and we can turn those on. And so that provides a nice layer of separation. It also separates your infrastructure from the internet, because this is all handled through secure networking on Amazon's side. And so people aren't actually hitting directly to your infrastructure. They're going through some layers, some proxy layers. The other tool that people don't tend to think about, and really we didn't think about until we were diving more in this, is ELB. ELB is actually a fairly decent security tool. It provides a layer of separation. It only does one thing. It just load balances the traffic coming in, and only load balances the traffic that you want coming in. And so leveraging ELB to protect your infrastructure also, adds that extra layer of separation between your infrastructure and the public internet. And so that's an easy tool to use also. So now network architecture. Okay, and so the other thing that we saw is Terry had the ability to pivot pretty badly within our setup. And so we have some network architecture guidelines that we didn't follow. We have your traditional 3-tier architecture model where you're really trying to protect your database layers so that your front-end layers aren't ever talking to them directly. We also like to, in this archetype of architecture, really limit the access between those layers, whether that be NACLs or security groups or firewall rules of some sort, so that things are only talking to what they need to talk to. And then finally, we need to probably limit outbound traffic so that things that don't need to talk to the internet don't talk to the internet. I mean, it's not needed. And so we can protect things there. So here's a picture of our original architecture. We had wide open NACLs, way wide open NACLs. As you saw, there was zeros all over the place, right? Security groups. I set it up not like pretending like I didn't know networking. So I just whitelisted what was easy, which is my VPC subnet, right? That should be safe. That's my network, right? And so we were able to see the security groups allowed the whole full VPC CIDR. Out of that, there was a lot of a lateral transition and a lot of movement that was able to take place. She was able to go from services that I thought were only talking to each other to services I didn't know could talk to each other by taking the WordPress site directly to the database. So this is not a good architecture. It's pretty wide open and fairly easy to get around. We also let all outbound traffic, so I wasn't protecting anything going out, right? I was letting it all come out of the network and not doing anything. So we can go to a better architecture, though, and really try to fit into this 3-layer network architecture. So we're going to say 3-layer, but we all know WordPress doesn't really fit a 3-layer architecture very well because it's presentation and application in the same layer. But we can still kind of fit it in here and protect things. So here what we've done is set up 3 distinct subnets and had very strong NACLs between all of them. And in that case, the front-end subnet, the first subnet, was only allowed to talk to the second one, and vice versa. The second subnet was only allowed to talk to the database layer and the front-end layer. And then our database layer was only allowing traffic inbound to it from the application layer, the middle layer here. We also cleaned up our security groups. So as opposed to just allowing all traffic from the VPC, we trusted only traffic from specific security groups. And so Our RDS database for WordPress only allowed traffic from the WordPress security group. That was the only thing that could take place there. Our RDS database, the super secret DB, only allowed traffic from the Lambda security group. So the WordPress site was no longer able to access directly to the super secret DB. We had NACLs in place protecting it. We had security groups in place protecting it to make sure things couldn't get back there. And so we were able to really limit the amount of pivoting that could take place in the account. The other thing we've done is we blocked internet. So a lot of the Amazon resources don't need internet because all of the loading and all the stuff happens behind the scenes in Amazon's infrastructure. Lambdas in the subnet don't need internet access. RDS databases don't need internet access. So we cut off internet access to a lot of those resources so that they're not able to exfil data directly and really minimize and lock it down. And now if we turn on VPC flow logs, we should see things only behaving this way. We can then monitor those, react to those, and say, okay, these things are talking, they shouldn't be talking, and be able to respond pretty quickly to those types of incidents.
All right, so what have we shown you today? We have shown you that attackers can use the same tools that your DevOps teams are using. Those are very powerful tools, and they allow you to do a lot of really cool things. If attackers can get your credentials, they can do those cool things too. The cloud APIs can really help you map out what is in the account and what you can attack and how it's configured, and that information is very useful for attackers who's trying to figure out how they can get at your data and how they can get at your systems. Then we showed you that read-only access. It seems innocuous, right? But it can be very powerful. It can give me a lot of information as to how I can attack your account. And then finally, wide open networks are a very powerful tool for an attacker. They make it very easy to traverse the network and to jump from one system to another, called pivoting. And so showed you how you can do some of that if the network is misconfigured.
Then from the blue team perspective, restrict access, minimize the amount of stuff people can get to, and have those locked down, to the bare minimum amount of roles. Automate the deployments. We talked about a lot of auto remediation. The more you run automation, the less likely you're going to introduce some type of human error or drift into the config. And if it's all automated, you can just keep running it over and over and over again to make sure your configuration stays the same. Architect your networks to minimize open ports for pivoting. So make sure that things can only talk to things that you want them to talk to. We're not able to cross boundaries where we don't want boundaries crossed. Protect your secrets. Don't embed them in code. Just because I store that Lambda function in an encrypted S3 bucket with a KMS key that I manage, Lambda creates a link that's good for a certain amount of time. Protect your secrets. Don't put them there. There's tools available. It's not difficult to start implementing and leveraging those tools to pull those secrets out securely. Okay? And then monitor everything. Amazon has a ton of monitoring tools built into it, a ton of event-driven ability with the event streams that you can subscribe to and then auto-remediate a lot of those actions. And so monitor everything and make sure it's all there. So we just both want to thank you all for coming to our talk. You can reach Terry on Twitter at Terry Radical or me at Colby Allen. We're here to answer any questions that you guys have, and thank you again.
There are a couple mics in the middle if anyone has. rules, or is it security groups you can only allow?
So NACLs will let you do more refined pathing on like your routing, where you can write a route that's broader, but then with the NACLs, you can refine that route, effectively only letting parts of that subnet through to different parts of your infrastructure.
Okay, yeah, I totally get it. You'd still have to call it AWS, which would be that address effectively, because it would like just be all of that site, right?
Yep.
The EC2 instance being exfiltrated. But it didn't have access. That is true.
The database was protected now.
No, he set up security group rules to block access to that, so that only that security group from the Lambda could only talk. Yeah. And the other one, so that's where he had the WAF in front of it and other security controls in it. Yeah.
Yeah, so, that was a problem I came up with once. And, effectively what we did is we wrote as tight of NACLs as we could, right? So what you have to do is, it's a gamble, right? You have to subscribe to the IP list. Make sure that you can respond fast enough that if something changes, it doesn't break something. So, it is an issue and it's a concern, and, it's something that you have to discover for your application what works the best.
Just want to repeat that question really quickly if you didn't hear it. The question is about some of the AWS services that require internet access. And yes, you do need to look at those on a case-by-case basis and decide if you want to use those services that are required to traverse the internet. But in some cases, some of these services don't actually go over the internet. They stay within the AWS network, so you can decide if that's okay or not. But it does make things challenging. I was just working with one of those the other day and talking to someone at AWS, about these changing IP addresses.
Yeah.
Right.
Yes.
Yeah, I expect more of those VPC endpoints are on the way.
Do you have a question?
Yeah, thank you. So I have limited resources when we're doing our war games or whatever system testing, so I'd like to focus more on the kind of damage that is done, not maliciously, but by overpowered audiences. Do you have any tips or tricks for identifying kind of obvious mistakes?
Well, so that's where I think immutability and automation become a bigger player in that is, whether you're using CloudFormation or Terraform, they're designed to be ran over and over and over. So you're reversing any drift that's happened. I think CloudFormation, last week released the drift feature now, so it scans your account and will identify drift actions, and then you can subscribe to those, or in the case of Terraform, just Terraform apply over and over again. That's a lot of what we do is just reapply the same templates over and over, and they'll back out a lot of those changes. That's also, though, where you start really having to be careful with scoping the credentials, is to make sure that, the users only have access to the things they actually need access to versus larger scopes.
So just for those who couldn't hear, I want to repeat that again. The question is, what do you do with people who have broad access an account? How do you deal with that? Ideally, we want to scope that down, but I actually wrote a paper on this topic, balancing innovation and security in AWS. And you have kind of the upfront model where you're trying to block things, and sometimes the security team doesn't have control over that. So the other side is the reactionary. And you can use tools like, Prowler or other tools that will scan your environment. Nessus has a tool that will scan AWS looking for problems. So it's just a matter of, using those scanning tools after the fact if you can't kind of get in front of people. There's a lot of tools out there.
Yeah. Well, so she stole the users. So the question is how do you protect, because, okay, so in the example here, you had to have a set of credentials to assume the role, right? So how do you protect and get someone using those credentials to do something? Well, that's was in the example is those credentials couldn't do anything, right? They could only change your password. So the most damage that Terry could do at that point is change my account password, because that's all those credentials allowed. She'd have to have the multi-factor authentication method to be able to assume the role into a privilege. So yes, she would still get a hold of creds. She could still do a few things like change password. But because we've required someone else to remove MFA, she can't go remove my MFA. And she can't read anything in the account, so she can't even go through and find out what roles could I assume. She can only say, oh, I can change your password, or change your name, or change your SSH key. And so there's still a little risk there, but because we've protected off, required the MFA for the other pieces, that we have that protected off. Yeah. Right, because if you want to be able to build an EC2 instance, we have a role that's EC2 admin. That's the only role that can build instances. You have to MFA into that. And because it's an EC2 admin, we say you can only have that role for 15 minutes. Right?
Yes,
so even if she were to steal them, she's going to only steal them for a very, very short period of time. And
that's configurable, because I know when developers are using MFA, they're like, I have to do it again, So you have to kind of balance out that time frame.
Yeah, so that's why, generally with read-only type things, developers are allowed to have that for 4 or 6 hours, their work day versus, an administrator set of credentials, you're requiring it off fairly frequently. But an administrator is going to be the type of person to be a little bit more conscientious of that and hopefully deal with it. Yeah.
So the question is sometimes use VPC endpoints, and they limit the traffic to things, within a particular VPC, but then what if those don't exist? What do you do in that case? DynamoDB. I think DynamoDB has VPC endpoints now. It's pretty new, but yeah, and it's a choice that you have to make. And so one of the problems with cloud is people rush to cloud and they don't understand the security controls, right? So you should make conscious decisions. We're going to use this service has appropriate security controls, and we're going to configure it properly. And I definitely, when we went to Capital One, we definitely went through and looked at every single resource. We said, does it require internet access, or can we lock it down within a VPC? And we were actually one of the companies pushing for security of S3 buckets. One of the reasons they came out with VPC endpoints. So yeah, you have to consciously make those decisions about what these services are allowing and if that's okay with you, according to your security policies. Yeah, otherwise you just have to, you have the traffic go over the network, you make sure it's encrypted over the network, you make sure it's authenticated, and you allow that to traverse the internet if you choose to do that. Oh, going from different accounts, there's definitely a new service, I think it was announced last year at re:Invent, called Private Link, and you can set up endpoints between accounts. It's similar to a VPC endpoint, I should have mentioned that just now. And you can set up endpoints with secure access and define what can access that between accounts. And there's also something called VPC peering if you want to peer 2 different accounts and allow them to talk to each other over the Amazon network. VPC peering will do that for you. So the question is there any best practice for MFA in your pipeline? I've never seen it published, but you can definitely put MFA if you set up your Jenkins server to use Active Directory to log in. You can definitely associate that with these third-party services that enforce MFA. That way, before someone logs in to run a job to deploy something, they have to use MFA to get into that. And you could also put MFA on your GitHub repo or whatever sort of source code repository you have. So there's definitely ways you can use MFA for that.
Yeah, so in that case, you tend to run your Jenkins server in AWS, give it a role and minimal set of permissions, or run multiple masters that can do different things, and then you protect the Jenkins servers or your CI/CD servers with MFA so that only limited amount of people can get into them. There's not really an easy way to inject. I mean, you could probably build a mechanism with a gate that requires an input of an MFA to do an assumed role type of a thing. But in that case, it's generally easier to protect the Jenkins servers and lock those down, put everything in front of them, and then give them a role to do the actions, and then run multiple Jenkins servers to minimize your role carryover.
So you've got a situation where some of these systems are fairly Byzantine and arcane, and you think you've locked everything down and gone through all the best practices, but there's some little pesky part that didn't have all the knackles applied to it, et cetera, et cetera. So my question is, what is your recommended belt and suspenders approach for how do I catch it when somebody gets past all of this clever stuff that I've done and things start to happen in the background? How do I set up CloudWatch alarms that will alert me before terrible things happen?
So I actually wrote a paper, the one I was mentioning, on security and innovation. And one of the things I did in there is I basically looked for blocked network, like deny traffic. Because if you think about denied traffic, it should never happen, right? Because if things are configured correctly, they should only be hitting allowed. And so you can look for something that's hitting denied traffic. You can also use guard duty, like Kobe mentioned, to look for anomalous behavior in your account, for example. On the network, if you have people who are allowed to make network changes, I'm not sure if this is what you mean, but there's a tool that we used called Dome9, a capital one, and it would monitor your account, and if someone created rules that were out of compliance, it would flip it back in 3 minutes. So there's a lot of tools out there that can help you with your configuration monitoring as well.
Yeah, I think that's the big thing is, if you think you have it locked down, just turn on flow logs and look for denies. Watch that pattern. I mean, AWS publishes Kibana dashboards for you to be able to visualize it nicely, write your own, and just start looking at it. I mean, you know what it should do, and so when things are starting to do things they shouldn't do, it's going to start standing out. But it just takes some time. I mean, that's the downside to it is you do it. That's why a tool like Guard Duty is pretty slick because it learns and will kind of build a profile for you right off the bat, and then be able to alert, and you can kind of go off that.
The other thing is we really learned, we had a small team at WatchGuard, just a small company, and we didn't try to do everything out of the gate. We just tried to create that pipeline so we could monitor. And then as we learned, that person did something we didn't want them to do, we could go back into that pipeline and build it in. Or if you don't have access to the pipeline, maybe you have some auto remediation or alerting on the back end. So it's a continually iterative process as you learn what people are doing and what they shouldn't be doing. There's also a cool tool in IAM if you have users where you can go look at what they've accessed in the last period of time, and you can see if someone's doing something they shouldn't, or if they have a lot of permissions they're not using, you want to remove them. I think there's 4 tabs when you go look at that user in IAM. You can check that out as well.
Awesome. Thank you guys again.
Yeah, one more?
Just one quick question. For getting data out of AWS, we primarily are from the outside trying to get useful data out. What would you say is the most preferred to least preferred authentication methods as far as keys with role assumptions, the worst just being keys with policies attached, and in the middle maybe being IAM roles on an EC2 instance if you have resources in there already? We often get customers asking what's best practice. So, if they're new, they just set up a set of keys, throw the accesses on, and that's what they use. Other customers want to use role assumption.
So you're talking about taking it out of AWS though, right? So
Yeah,
if you're
talking about how to secure it. So I am coming from outside.
If you're outside of AWS, you have the challenge because you don't have the keys outside or the roles outside of AWS, right? So you're going to have to think about some sort of authentication mechanism. And I would really suggest if you're in a company that you use Active Directory if possible instead of those developer keys, because if you think about it, when someone leaves the company, you want to be able to quickly shut down their access. Anyone with those keys can use those credentials. When it's an Active Directory, you could quickly shut them down, or if they move roles, you could change them. So if you're within a company and you have Active Directory, I would say use that. If you're not using Active Directory, if you're using, especially if you're using a SaaS application, make sure you have per device or per user credentials. Don't just have one API key. And there's a really good standard that's come out for authentication that I like called FIDO, F-I-D-O. And it really talks about, like, for example, you're authenticating from a cell phone or something like that. Not just cell phone, but it's a really good authentication standard to take a look at.
Yeah, this wouldn't be a shared key. It was just along the lines of for a dedicated key for a service-based consumption.
Yeah, I would say take a look at FIDO if you can, and just, you know, if you're in a company using Active Directory, but if you have a third-party service, you're going to want to look at. I like FIDO because you really have a private identity that authenticates to the service, and only that identity has their keys. I actually looked at an authentication service that a company was acquiring, and it had, you know, kind of a different model where it had administrators administrating keys. And I'm like, well, if any two people can get that credential, you can't count on that being identity for that user. So you want to get in that mindset, and FIDO has some really good recommendations in that case. Thank you, everybody.